Alright, good morning. Quite a bit of an issue we have here with our morning class. Not many people have joined, so that's a little bit of an issue. But that's okay. We'll work with what we have. So we're just gonna wait for a couple more people to show up and then we will get started. So the work we're working on today is 6.4 and 6.5. I should actually change the title of our video here. So there we have it. Yeah, so we'll wait until 11:05 and then we'll get started once everyone gets here. If you have any questions or you want to talk, please feel free. If you have any questions on the commenting, please ask me as well, and I'd be happy to answer any questions that you might have. Alright, we got some more people joining up, which is great. We're still waiting for more people to show up. We're still going to wait until 11:05. Probably people are saying, like, oh, Mr. Choi is going to wait till 11:05. I feel like I should just start at 11, just so that people who come late, come late. Maybe that's a better option. But we'll see. Two more minutes. 2 more minutes. Hope you all are having a great week thus far. We're already past halfway. Almost Friday. It's almost the weekend. But I got some bad news. Good news for some, bad news for others. We'll talk about it. Hello, Yazdan. Good morning. Good to have you join us. Okay, so this sheet you should have open is as follows. Why is there no signal from my camera? What do you mean there's no signal? Interesting. Looks like we're having some technical issues. That's not good. try to get that all sorted out. Can I write the equations yesterday you posted in Google Classroom notebook and take a picture of it? Yeah, absolutely. If you want to do that, you can definitely do that. Let's try this again. Not sure why this is having so many issues today. Hi, sorry about that, guys. My stream setup just crashed real quick while it was setting up, so hopefully it's all back and we're still good to go. Make sure you click on the live button on your video chat because it might have been a little off sync now. Good morning, Gyujin. So we got 7 people watching. We're just gonna get started. Sorry for the late start. Had some issues with the camera. I should probably get that fixed before I start next time. So far we talked about quadratic equations, finding roots by factoring, how to get the vertex form by completing the square, and getting the roots from the vertex form. So the question here is, what about this one here? Can we factor, when it asks you, does it have any roots? It's asking us, can we factor and find the x-intercepts? And so looking at my b value here, so a is 1, b is 3, and c is 1. But the thing is, we don't have any numbers that multiply to 1 but add to 3. Good morning, Stephen. So, like, 1 times 1 is 1, but 1 plus 1 is 2. So this is not factorable. However, it should have roots. So we can complete the square. We can try completing the square and figuring this out. So maybe we can do x squared plus 3x. We have that in brackets. Plus 1 equals 0. And then we can divide by 2 and square it. We get x squared plus 3x plus 9 over 4 minus 9 over 4 plus 1. And then factoring this all out, I'll just skip to the end here. Now I'm going to stop here. So this is completing the square that we did yesterday. I'm going to take the middle number, divide it by 2 and square it, and that gives me these. I'm going to pull out the minus 9 over 4. I'm going to complete the square. And I get to this point. And a lot of you are probably thinking, wow, that's a lot of work to do roots, right? And now we have to solve for this. Like, we have to actually do the math. Like, we have to move this to the other side. And then square root it. And then we have to do subtract the fraction. Like, to say that these are the roots, this is complicated. This is overly complicated. Like, this is a lot of work just to get roots. So we can't factor it. That doesn't mean it doesn't have any roots, right? Right? So we can say not factorable doesn't mean there are no roots. And all it means when it's not factorable is that we can't really factor it using our regular methods, right? So But when we do completing the square, it becomes really complicated to even try to solve for your roots. So we know they exist, but man, that was a lot of work, and that's kind of annoying. So we actually have a formula that we can use to find roots. Okay, so this is important. This here, I will give it to you every time, but I highly suggest you memorize it. I've memorized it, right? If I cover it up, right, I can just say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's something you just have to practice, and you get it over time. This gives you the roots of the quadratic equation. Okay, so this gives the roots of your quadratic equation, so it's important for you to understand and know how to use it. The a, b, and c are just the coefficients of your quadratic equation in standard form. Okay, so when we look at this first example that we did there, I'll write down a is 1, b is 3, and c is 1. Okay, you write down the three coefficients. Make sure you include the sign. If it's positive, it's positive. If it's negative, it's negative. I'm going to copy down the equation. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to copy that down. Now I'm going to plug in my numbers. X is equal to negative, my b is 3, plus or minus the square root of b squared, which is 3 squared, minus 4 times 1 times 1, all divided by 2 times 1. So all I've done here is plug in all the values of a, b, and c into the corresponding variables in the formula. So that step is something you should know how to do. You should know how to plug in numbers when you're given, like, oh, x is this or y is that. Like, you can plug that into your equation. This is the same idea. Once you have that written down, we can say, oh, x equals, now we expand. Negative times 3 is negative 3. Plus or minus the square root of 3 squared is 9. Minus 4 times 1 is minus 4. All divided by 2 times 1, which is 2. Let's keep going. X is equal to negative 3 plus or minus the square root of 5, all divided by 2. Now we turn it into two situations. There's two answers to this. One is where it's the positive form of your square root, and the other is the negative form of your square root. So this left side here, we'll use the positive, and on the right side, we'll use the negative. Now, I get a question very often, like, do we have to solve this? If I ask you for exact answers, that means no estimating, no rounding, then you leave it in the square root form. If it's not a perfect square and you can't solve that square root. If I ask you, round to the nearest 10th or 100th or first decimal place or second decimal place, then you would actually solve the square root and give me the decimals. Okay? So you can leave it like that. And this is using the quadratic formula. There's your two roots. And I can ask, like, what are your two roots? You have this and that. Okay? So let's go through more examples of how to do it. Now, a question that I also often get with this is, like, do we even have to factor at a certain point if we want to do the quadratic formula? And the answer is no. That you're absolutely right. If the quadratic formula tells you the roots, you don't have to factor or anything like that at all, right? You get the x-intercepts and you're done. The issue is when I tell you factor it and you do the quadratic formula, that's going to be wrong. So if I just ask you, what are the x-intercepts? Yes, you can pick factoring, you can pick completing the square, you can pick quadratic formula, like whatever method you do it, that's your choice. But if I specifically state that I want factoring done, then you have to use factoring. So hopefully that clears up any questions and concerns that you may have. So let's go to question B. I'll do it in black so it doesn't, it's a little different here. So A is 2, B is 4, and C is negative 10. Okay? A is 2, B is 4, C is negative 10. Okay? So I have the formula here. I'm not going to copy the formula. If you, I suggest you do, in case like you're trying to learn it and memorize it and kind of keep it here beside you. If you have the formula beside you anyways on another piece of paper, that's different. So if I write it out, I'll go x is equal to negative of 4 plus or minus, the square root of 4 squared minus 4 times 2 times negative 10. Maybe I should have made more space here. All divided by 2 times 2. Notice how the signs are kept when you substitute. It's important. So if I expand this out, I'm going to get negative 4 plus or minus the square root of 16 plus 80, all divided by 4. And the reason why it becomes plus 80 is because it's negative 4 times 2 times negative 10, which will give me positive 80. And so simplifying what's inside the square root, it's going to give me 96, all divided by 4. Okay. Any questions so far? I think we're good. Just going to let some people copy down that value there. So now we have square root of 96. That is not nicely square rootable. However, when we get to this fraction here, 4 is divisible by 4, right? If 4 is divisible by 4, we can actually simplify that and just move this denominator over to the right side. So I can simplify this to this. So notice how I have divided the first integer with the denominator, and I've just moved the fraction over there, making it nicer and easier to read and write. And so now we get our two situations here, where it's going to be minus 1 plus root 96 over 4. And on the right side, it'll be x equals negative 1 minus root 96 over 4. And there's our two answers. Okay. So as you get practice and as you get comfortable over time, this becomes a lot faster and easier to do. So, when we move to question C here, some of you may be like, oh, that's a difference of squares. I can easily factor that. Let's say you forgot. Let's say you forgot. For whatever reason you forgot, oh, I don't remember how to factor it. That's fine. You can always use the quadratic formula. In this case, A is 4, B is 0, and C is negative 9. Okay? So now we have our three numbers. We can now plug it into our formula. So negative of 0 plus or minus the square root of 0 squared minus 4 times 9, or negative 9, sorry. All divided by 2 times 4. Right, it's pretty simple so far. We're constantly just plugging in numbers into the quadratic formula. Pretty quick, pretty easy. Solving that out, I get, well, negative 0 is just 0. So that's gone. So I'm just going to write plus or minus the square root of 0 squared, which is 0, minus 4 times 4 times 9, which is 144, and it's going to be positive 144, all over 8. I'm going to simplify that. X is equal to plus minus 144 over 8, which I can simplify to plus or minus 12 over 8. And so I'm going to situate or change that into two numbers. That's going to give me x is equal to 12 over 8, or x is equal to negative 12 over 8. And so writing that out in the end, simplifying the fraction here will give me 3 over 2, and this will give me negative 3 over 2. And there's our two roots. So I'm just going to zoom out a little bit so people can see and copy down whatever they need to here. All right. Does anyone have any questions so far on the quadratic formula? I think it's fairly straightforward. It's just like you don't even have to worry about memorizing it, because I'm usually going to give it to you, or you should have it with you now anyways. It's just a matter of, can you plug in the correct numbers in the correct positions? And then from that point on, do you know how to do bedmass? To which I would hope that most of you will say, yes, I know how to do bedmass, and yes, I know how to substitute my numbers. That's important. Okay. All right. So that was the first part. You do have homework numbers here. That's for some extra work. It seems like a lot, I know, but it's just using the quadratic formula. Just do as many questions as you feel makes you an expert or comfortable at in this section. But let's go to our second part of the lesson, which is kind of using those roots and interpreting what they mean. Okay? And this will lead us into like word problems and such. So it says here, determine the roots of each equation. You can do this in whatever method you like. Okay? You can do this in whatever method you like, whether that be whether that be factoring or quadratic formula, that's up to you. Okay? So looking here, if you think you can factor that, you can absolutely try. Think of 26 and negative 12 numbers that multiply to 26 but add to 12. I'm trying to think of any. 13 and 2 don't work. I think that's pretty much it. 26 and 1, 13 and 2. 4 doesn't work, 3 doesn't work, 5 doesn't work, 6 doesn't work. So this would be pretty hard to factor. Just looking and thinking of those factors on top of my head, just before I even write anything down, I'd be like, okay, that's a little bit hard to factor. Maybe we can just use the quadratic formula. So once again, I'm going to write out the quadratic formula. I'm going to write out my numbers first, sorry. A is 2, B is negative 12, and C is 13. So I'm going to write that out. Second, I'm going to write out my quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. I know there's like a song for this too. I don't remember what the song is, but I mean, if you want to memorize it by song, by all means, do that. So solving that out, x is equal to negative 12. This is important here. That negative doesn't mean that the number there is all automatically going to be negative. That negative is already there in the formula, which means when you're plugging in a negative number, it better be in brackets. That's important. I see a lot of students make that mistake. Then this plus or minus the square root of negative 12 squared minus 4 times 2 times 13. All divided by 2 times 2. So we have that number out. I'm going to write on the left here more so we get more space. So I have 12 plus or minus the square root of 144 minus, and it looks like it's going to be 8 times 13, which gives me 104, all over 4. We get this situation here where 12 is divisible by 4, so I'm going to simplify that first part into 3 plus or minus the square root of 40 all divided by 4. Okay. Now we can continue on, separate it into 2 sections. So x is equal to 3 plus the square root of 40 over 4, and x is equal to 3 minus the square root of 40 over 4. Okay? So there's our values, or our x roots here, our x-intercepts or our roots. Okay? So quadratic formula, just like we just learned, we can quickly find the 2 roots of our function. For b, this should be really quick if you're good at factoring, or if you identify this as a special factor. Done. Special factor, no need to show any other work. That's a perfect square trinomial. Done. Nothing else to see here. Okay? So you're done. It's good. So what are my roots? Just x equals 3 or x equals negative 3. That's my root. Just one root, right? Because the bracket is multiplying by itself. It's a square. That root is itself, right? So x equals negative 3. That's the only single root that it has. And that we can just do by factoring. Yes, you can do quadratic formula, but that would take longer than it is to just quickly factor this. Okay, so there are situations to use one or the other. Quadratic formula takes a little longer, but it'll always give you the right answer. Factoring will be faster and quicker as long as you can do mental math quickly. But the question is, like, for something like this one was easy in comparison to this. Like, how can we tell if there are even roots here? And that's what we're going to learn today. Like, how do you quickly determine, is there even a point in doing the quadratic equation? Is there even a point in solving or by factoring, right? So when I ask you, how many solutions can a quadratic equation have? A quadratic equation can have, and then I'll do number 1, or no roots, 1 root, or 2 distinct roots. In other words, 2 different roots. Okay? There's 3 situations we need to talk about. Okay? No roots, 1 root, 2 distinct roots. Okay? Now, what helps us determine that is our next portion here. The discriminant. It helps us determine how many solutions a quadratic relation has. The discriminant is this formula here. And this is our 3 situations. Now, this part should look familiar. It is the portion of the quadratic formula that is in the square root. So if I quickly write the quadratic formula here, b squared minus 4ac is the discriminant. That is the portion that's inside the square root. And the reason why that's important is because of this formula, within this formula, the part that restricts you from having different solutions is the square root itself. So let me explain that. If what is inside the square root is negative, there are no real roots. That's this bottom portion here. The square root of a negative number does not exist, which means this formula would fail because there's no roots. That's the bottom situation here. The second situation is that the square root of 0 is 0. So when the discriminant, what's inside the square root is 0, there's only one real root, which means you're left with just negative b over 2a. And the last situation is where what's inside the square root is greater than 0. It's a positive number. In those situations, you can square root any positive number. That must give you two numbers where it's a positive and a negative. And that's our two situation cases here. Okay? So once again, this is your quickest way of determining, hey, are there roots? Yes or no? How many roots are there? So you're going to get situations where I might ask you, how many roots are there for this quadratic equation? Don't solve it. Don't tell me what the roots are. I don't care what the roots are. Can you tell me if there are roots and how many there are? And in those situations, you will be using this discriminant and understanding that there are three situations that can come out from your discriminant. So let's go through some examples with this. Make sure you have that discriminant section open. Okay, so once again, at the beginning here, without solving, determine the number of real roots in each equation. So don't solve it, just figure out how many roots there are. So the first thing we're going to write is always going to be what's A, what's B, and what's C. So A is 3, B is 4, and C is 5. So now let's determine what our discriminant is. So my discriminant is b squared minus 4ac. So I'm going to plug in my numbers. That's 4 squared minus 4 times 3 times 5. I'm going to get d is equal to 16 minus 60. And d is equal to negative 34. So now we look back at our previous situation here where, now let's look at our three situations. So first we can identify that d is less than 0. It's a negative number. Therefore, right? And then we just quickly look here. D is less than 0. That means there are no real roots. Therefore, there are no real roots. And you're done. If you were to graph this quadratic equation, you would see a parabola that opens up that does not have any x-intercepts, which means it's above the x-axis. Okay. The next one here, same idea. A is negative 2, B is 4, and B is 7, and C is 1. Okay. Solving out using our discriminant, b squared minus 4ac. B is 7, A is negative 2, and C is 1. This one you can quickly tell that it's going to be a positive number. Oh, whoops, that should be 57. So we get D is equal to 57. And so D is greater than 0 this time. So therefore, once again, looking here, there's two distinct real roots. Therefore, there are two distinct real roots. And there's our situation there. And our last one here. Okay. Last one here. We have A is 9, B is negative 12, and C is 4. Plugging in our into our discriminant, B is negative 12 squared minus 4 times 9 times 4. So we're going to get D is equal to 144 minus 16 times 9 is 144. So I get D is 0. So we can say D is equal to 0. Therefore, we go right here. In our situation, D is 0, so there's one real root. So therefore, there is one real root. Okay? And then you can finish solving it. Pretty simple. Okay? Now, we have more examples here. Without solving, determine the number of zeros for these two situations. I'm going to have you do this on your own for practice. But the main thing you want to understand is that before you even plug it into the discriminant, you can only use the quadratic formula and the discriminant when your equation is in standard form. Okay? So I'm going to write that as a note here. To use the discriminant or the quadratic, or I'm going to say the quadratic formula sorry, let's fit that on the screen. To use the discriminant or the quadratic formula, the quadratic equation must be in standard form. That's important. That is a very important note that you should write down for our lesson today. Okay? So when we solve our equation here, this one here, so y is equal to negative 2 bracket x minus 4 squared minus 3, I need to expand this first. So I would fully expand this, like as I am doing now. And then once I have expanded it, then I can write down what is A, what is B, what is C. You can't write it down until you have fully expanded it to standard form. So once again, I'm going to bring that up on the screen so you can see it and copy that down, and I'll let you complete the rest of it for work, and you have homework at the bottom there as well. Okay? So, as you finish copying that down, I have a couple of announcements to make. Or at least just like one or two. So, announcement number 1, for your culminating assignment, once again, the soft deadline for that part 1 is next Wednesday. Okay, next Wednesday is your soft deadline. Yes, there are concepts there that I did not teach, but yes, you can look forward into your textbook and kind of learn it yourself and start learning it yourself. I'm probably going to start teaching that section early next week. And so, yes, if you can finish it by Wednesday, that would be a good timeline because you are getting part 2 starting Wednesday. I don't want to overwhelm you with too much work. So please keep that in mind. Number 2, let's talk about tomorrow. Tomorrow, you will have your first quiz with me. So tomorrow there is no lesson. There's no live stream. There's nothing happening here. If you want to schedule an extra help session with me tomorrow, please email me. We'll schedule a Google Meet session and then we'll work something out. But otherwise, you'll be getting a Google Forms quiz tomorrow at 11 a.m. I'm going to be posting an announcement tomorrow morning as well. So for those watching the video, you know now. You don't have to tune in at 11 a.m. You don't have to wake up early. Relax, sleep in, whatever it is. And then you'll have the weekend to do the quiz. Okay? I highly suggest you finish the quiz by Monday. The deadline is technically no deadline, right? But let's get on top of it because we're going to be jumping into chapter 7 next, like on Tuesday next week. So next Monday we're going to be talking about application questions about quadratic stuff, and then we jump into chapter 7 on Tuesday. So like I said, we're rushing through this stuff. We're making sure we get all of our course content done because we need to catch up. We're a whole unit behind, and I'm going to do my best to catch you up without losing the core details and the important parts of your course. Okay? So there's a lot that we have to do. So tomorrow, there's a quiz. It's Google Forms. You fill it in. I'm going to just import the grades onto Google Classroom, and I'll update the marks. Tomorrow, I'll also be updating any math space marks onto Teach Assist. So by Sunday, over the weekend, you should have an updated mark on Teach Assist. And if I forget, please email me and be like, hey, I don't think it's updated. Can you please check that? And I'd be like, yeah, sure, I'll check it. But I will put an announcement if I have successfully updated all the marks that I received on MathSpace for your 2 assignments that I extended. Okay? So hopefully that answers all the questions. Otherwise, take care. Have a good one. Enjoy your weekend because once again, no class tomorrow. And I'll see you in the next one. Bye-bye.